Previously we took a look at quadratic equations and the graph involved. So we took a look at graphing diver off the diving board and the rocket going through the air. So what we're going to look at today is actually application word problems. So again, application means we're dealing with some type of real world situation, and we are dealing with word problems where we have to pick out the important information. So as a little warm up, I gave you 5 as a root of this particular equation, x squared minus 3x plus k equals 0. We need to find k and the other root. So first things first, we know that if x equals 5 as a root, that means if I were to solve it in order to get a binomial, I have to get this to equal to 0. So we're going to subtract 5. So as a binomial, we get x minus 5 equals 0. So first thing, we know one of the binomials is going to be x minus 5. But we don't know what the other one's going to be, but we do know it equals to 0. Now we do know this was factored, so what's going to go inside this other parenthesis? Well, we know the first guys have to multiply to be x squared. So the only thing that's going to multiply to x squared is x times x. Now for the number part, we know the number is going to multiply to be k and add to negative 3. So that's what's going to help us out. What number do I have to add to a negative 5 to get negative 3? So negative 3, I'm going up the number line further. So I'm going positive, and then the difference between the two, 5 and 3, is 2. So we end up with x minus 5 times x plus 2. Now the question is to find k, so we know the two numbers are going to multiply. So negative 5 times 2 gives me negative 10. So k is going to give me negative 10. Now the other root, we already took care of the x minus 5 bit to get 5. So now what we want to do is we want to figure out what the other root is. So we already took care of the 5. Now we're dealing with x plus 2 equals 0. So I'm going to subtract 2 from both sides, and the other root ends up being x equals negative 2. So there's the other root. So one root was 5, the other root is negative 2. When it comes to application word problems, quadratic equations, a lot of times, most of the time, we're going to be dealing with the letter t. T is going to be time. Now this could be seconds, minutes, hours, it really doesn't matter, just dependent on the problem. And this is going to be your x values. So you're used to seeing x squared, you're going to be seeing t squared. So it's essentially the same thing. H or d is going to be your height or your distance, and this is going to be your y values that you're used to seeing. And when we hit the ground or water, the height is going to be equal to 0. So first things first, what I want to do is answer these particular few questions pertaining to this particular problem. After t seconds, we got a ball toss in the air from the ground level, reaching a height of h feet, given by the equation h equals 144t minus 16t squared. What's the height of the ball after 3 seconds? So fortunately for us, we have an equation. We're told what the time is, so all we have to do is plug 3 in for t. So we know h is equal to 144 times 3 minus 16 times 3 squared. So when I go in here, we have 144 times 3 minus 16 times 3 squared. So we have 288 feet. So at 3 seconds, our height is going to be 288 feet. Now, what is the maximum height of the ball that it could reach? Well, first things first, we got to plug in our equation, 144x minus 16x squared. So again, looking at a graph, not necessarily going to help. It's easy, we go way up and then we come way back down. So that doesn't really help us. So we'll go take a look at the table, and I see that at 4 and 5 seconds, we have the same value, 320. Now with a parabola, there is a specific turning point it goes back up and it goes back down. So this tells me we're somewhere slightly above 320 feet, and we're somewhere in between 4 and 5. Now what we have to do is we have to change our table. So in yellow, table set. Now it says table start at 2. Well, I want to do 4 because we know it's between 4 and 5 seconds. And the change in table, I'll make it 0.1. And then I go back to the table. And I look to see what's the maximum height. Is there wrap around going on? We got 44, 56. So here we have wrap around 322.56 to 322.56. I see at 4.5 we reach a height of 324. That is going to be the maximum height. So again, if you get a situation in that, we can always change the table to one that is beneficial to us, and we can see that the maximum height of the ball is going to be 324 feet. And then letter C is asking, after how many seconds will the ball hit the ground before rebounding? So we know that the ground is 0. So all we're going to do is make sure our equation is set equal to 0. 144t minus 16t squared. So just like before with any other equation, first thing we look for is the greatest common factor between our items. So first thing, check our numbers. So in our generic screen, math, pushing over to number is going to give us the menu that we want. For number 9 is GCD. And we're going to put in our two numbers, 144 and 16. So I can pull off a 16 from both of these. So I can divide each of these by 16. And I can also divide off a t. They both have at least one t, so I can divide off a t. So we end up with 0 equals, and then I'm going to divide 144 by 16. We get 9. And then negative 16 minus 16 gives me 9 minus 1. T squared divided by t is just t times 16t. So there is, actually, I'll change that up. So whenever we divide off a common factor like that, whatever we divided off comes down. Whatever I get left goes inside parentheses. 144 divided by 16 is 9. T divided by t will cancel out. Subtracting, 16 divided by 16 is just 1. T squared divided by t is t. So now what I want to do is I want to split these up and set them equal to 0. So we have 16t gives me 0, and 9 minus t gives me 0. So what I'll do now is on this side with the 16t, I'm going to divide by 16. So t gives me 0. 0 divided by 16 is 0. Now 9 minus t, the easy way, t has to be positive. Here we're subtracting. So if I add t to both sides, 0 plus t, last time I checked, anything plus 0 is itself. So the negative t and the positive t will cancel out. So we have 9 equals t. So again, the question is how many seconds until I hit the ground before rebounding? Well, we start at 0, so that doesn't really apply here. So we're going to ignore that. So that means 9 seconds. The ball is in the air before hitting the ground. Now the second problem, we have a rocket carrying fireworks launched from a hill 80 feet above a lake. The rocket's going to fall into the lake after exploding at its maximum height. Rocket's height above the surface is given by this particular equation. And we have to answer these 4 questions. So the first question is, what's the height of the rocket after 1.5 seconds? So again, 1.5 is our time. So we can plug it in for time. So h equals negative 16 times 1.5 squared plus 64 times 1.5 plus 80. And then what we can do is negative 16 times 1.5 squared plus 64 times 1.5 plus 80. Gives me 140. So after 1.5 seconds, we're at 140 feet. And letter B asks what's the maximum height. So what I'll do is I'll go back, change the table. I'm going to start at, change the table is just going to be 1. And I'll start at 0. So we go to y equals negative 16x squared plus 64x plus 80. And I want to take a look at my table and find some wraparounds. So as long as we have a wraparound and it looks nice, we see 144 solidly in the middle. Therefore, 144 feet is going to be our maximum height. Letter C, how long will it take for the rocket to hit 128 feet? So we know what the height is. So we can actually plug this into our equation. So instead of knowing time, we know height. So 128 gives me negative 16t squared plus 64t plus 80. So what we want to do here is we want to figure out values of t. Now, in order to do this, equation has to equal 0. So I have to subtract 128. So we get 0 equals negative 16t squared plus 64t. And then 80 minus 128 is going to give me negative 48. So now what I want to do is I want to see if there's anything I can divide off that is going to give me a nice answer. So we'll quit, and what we can do is we can try and find the common factor between all of these. So again, math over to num, GCD is number 9. Now the calculator cannot do 3 at a time, however there is a workaround. After we put in the first number, again they all have to remain positive. It doesn't work nicely with negative numbers. So 16, comma, and then I'll do the same thing again, math, number, GCD, and then I'm going to put in the other two numbers, 64 and 48. 16. So this means I can divide all 3 by 16, and because I like t squared to be positive when we're trying to factor, I'm actually going to divide by negative 16. So if I were to give me a little more room, I'll go over here. So 0 equals, I was able to divide off in negative 16. I can't divide anything else because we have t squared, t, and nothing. So when I divide that off, negative 16 divided by negative 16 gives me t squared. 64 divided by negative 16, so minus 4t. And then negative 48 divided by negative 16 plus 3. So I was able to divide off a common factor. Now what we can try to do is factor this trinomial. So 0 equals negative 16. If I can factor it, I'm going to end up with 2 sets of parentheses. And the first guys are going to multiply to t squared. So the only way that's going to work is t times t. Now the numbers have to multiply to 3 and add to negative 4. Well, the only numbers that multiply to 3 are 3 and 1. So how do I get a negative when I have to multiply to a positive? Well, the only way I can get a positive through multiplication is a positive times a positive or a negative times a negative. Because my middle term is negative, that means negative and negative. Now what I want to do is I want to figure out the time at which I'm going to be hitting our value here. So Our value is 0. Again, I'm going to ignore the negative 16. There's no t involved. There's no time involved with it. It's just a common factor, so I'm not going to worry about it. The only thing I'm going to worry about is my t minus 3 and t minus 1, which I will set equal to 0. What I'm going to do is add 3 to both sides, and we get time equals 3. And then on the other side, I'm going to add 1 second. So we get time value of 1. So this means I have 2 separate times at which it will hit 128 feet. I got one time value at 1 second, and I have another time value of 3. So those are, so we have 1 second and 3 seconds. So this means I went up. At 1 second, I hit a 28 feet, and in between 1 second and 3 second mark, I went up and came back down, and I hit 128 feet on my way back down at the 3 second mark. So the other question, it says, how many seconds after it's launched will it hit the lake? Well, the lake, we have to keep in mind that our equation again, we're basically going to do the same thing. After how many seconds are we going to hit the lake? Well, our original equation is negative 16t squared plus 64t plus 80. The lake is at 0. So what I want to do now is I want to see if I can divide off a common factor between these three numbers. So again, math over to num. Number 9 is GCD, so 16, comma, and then we do the same thing. In this case, 64 and 80. Again, I have to do this twice. I have to do the GCD twice because the calculator can only do 2 numbers at a time. So if you have 3 numbers you're trying to find a common factor for, it's the common factor of the first number and the common factor of the other 2 numbers. And again, we can divide off of 16. So again, because I like our leading term to be positive, I'm going to divide everything by negative 16. So we end up with 0 equals negative 16 times, and then t squared minus 4t minus 5. So again, 16 is just a solid number. I can't do anything about it. However, I want to see if I can try and factor this trinomial. So if I can factor it, I can break it up into 2 sets of parentheses. T times t is the only thing that's going to give me t squared. And the numbers have to multiply to negative 5 and add to negative 4. So the only thing that multiplies to 5 is 5 and 1. So question becomes, how do I get a minus? How do I get a minus when I multiply? Well, the only way I can get a negative answer is if I have a positive times a negative. Question becomes, which one is which? I take a look at the middle term. Whatever value the middle term is, the bigger number in my 2 binomials will get that. So the middle number is a minus. So this means the bigger number between these 2 sets of parentheses is going to get minus. So I look at 5 and 1. 5 is bigger than 1, so that's going to be minus. So t plus 1. Now what I'm going to do here, I'm going to bring it up here. So we have 0 equals negative 16 times t minus 5 times t plus 1. What I'm going to do is I am going to only worry about the parts that have a t involved. So negative 16 on the outside is just a number. I'm not going to worry about it. But here in parentheses, we got t minus 5 and t plus 1. Each of those is going to get set equal to 0. So t minus 5 is 0. T plus 1 is 0. So solve each one for t, add 5. So we get t equals 5. And then the other one, we're going to subtract 1, and we get t equals negative 1. So again, because this is a real world application, how many seconds will we hit the lake? Well, time value of -1 means -1 seconds. So it's not possible to go backwards in time. Therefore, t equaling -1 is not a viable solution. Therefore, 5 seconds being a positive time value, that is going to be our answer. It's going to take 5 seconds for our rocket to hit the lake. And the last problem here is number 3. We got a rock thrown from the top of a tall building. Distance in feet between the rock and the ground, t seconds, represented by the equation d equals -16t squared minus 4t plus 382. How long after the rock is it 370 feet from the ground? So here we have the height d, and which we can plug it into our equation. So instead of d equals, we have 370 equals -16t squared minus 4t plus 382. So I want to get this equal to 0. So we're going to subtract 370. So we get 0 equals -16t squared minus 4t and then plus 12. So what we can do here is we can look to see if there's a common factor, but it's not going to help us out because unlike the other problems, notice I was able to get just t squared in our parentheses. I'm not going to be able to do that because I cannot divide everything by -16. It would not cancel out the leading coefficient. So this means we have to use one of our other methods of solving. So we can't use common factor. We're not going to attempt factoring the trinomial. We don't have a difference of two perfect squares. So this goes back to the other two possible methods of solving: completing the square or the quadratic equation. Completing the square means t's are on one side, my number 12 will be on the other. Quadratic equation means our equation is set up equal to 0. We are equal to 0, so we are going to use the quadratic equation. So again, quadratic equation is available to you on the reference sheet. Also, if you memorized it, that's nice. You don't really have to. It's on the math reference sheet, available to you whenever you want to use it. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So again, this is a solid, set in stone, foolproof method of figuring out values of t, and it always works. So a, b, and c go right down the line. A is going to be -16, b is going to be 4, and c is going to be 12. So all I'm going to do is plug these values in. So we have the negative value of -4 plus and minus the square root of -4 squared minus 4 times -16 times 12 all over 2 times -16. So we go through and simplify -4. I change the sign, becomes 4 plus or minus the square root. So what we'll do is -4 squared minus 4 times -16 times 12. I end up with 784 all over 2 times -16, -32. So what I'm going to do here now is I'm actually going to split it up. So we want to know approximate time. So we don't really care if we end up with a decimal time or not, because we can have decimal times. It's possible, it's feasible. So because we're adding and subtracting the square root of 784, I'm going to split it up into two equations. So we get 4 plus the square root of 784 divided by -32, and I get 4 minus the square root of 784 over -32. And what I'm going to do is I'm going to do each of those. So 4 plus the square root of 784. And we divide by negative 32. So we get negative 1. So we get time value of negative 1. And then if I do the other one, 4 minus the square root of 784, negative 24, divide by negative 32, 0.75. So how long after the rock is thrown is it 370 feet from the ground? Well, negative 1 is not feasible because we can't go back in time, whereas 0.75 seconds is feasible because we're going forward in time. So we're going to cross off that, and our answer is x equals 0.75. So again, that is quadratic equation for a problem that we cannot factor nicely, whereas the others we were able to use greatest common factor and trinomial factoring to figure out time values. So again, real world applications, we have to take into account time is a real value. We cannot go backwards. We cannot have negative time values. So therefore, any time value that ends up negative is most likely not going to be a viable answer. So we have to keep that in mind. Otherwise, everything is exactly as I showed you, and we can use all our available factoring methods to figure out the answer to particular word problems pertaining to quadratic equations in real world situations.